Welcome you all in the first lecture of Abstract Algebra MTL 6051. In this lecture, we will going to discuss basics of number theory and relation and function and classification of function. In few lectures, we will discuss all these topics. After that, we will move on group theory. Right? Let us start number theory. In number theory, the classification of fundamental sets. Fundamental sets means sets, natural number, rational number, integers, real number, complex number, right? The classification are as follows. This capital C is the set of complex number. Set of complex numbers. Right? And set of complex number, element of set of complex number can be written as x plus iy. What is xy? Xy is real number. Right? Then there are two parts. One is imaginary and one is real part. Right? Imaginary part, for those numbers are imaginary, is under within square root some negative sign. Right? For example, -4. This is an imaginary number. Right? Square root of -3. This is an imaginary number. Cube root of -2. This is imaginary number. Right? Then complex number is divided into two parts, imaginary and set of real numbers. Further, the classification of set of real number into rational number and irrational number, that is q and q complement, that is r is equal to q union q complement. Right? What is rational number? Rational numbers are two types. Is fractional number, fractions, and another one is integer. Right? Fraction, for example, 1/2, 3/4, etc. An integer can be further classified into three categories: negative integer, zero integer, and positive integer. This positive integer is known as natural number, including 0 and n. This is known as whole number, and negative integer is denoted as z minus. Positive n is also denoted as z plus. Right? Then capital N, set of natural number, is the subset of whole number. Whole number means non-negative numbers. Is the subset of z. Z is the subset of rational. Rational is the subset of real. Real is the subset of complex. Right? What is natural number? 1, 2, 3, 4 up to infinity is known as natural number. What is whole number? Whole number is 0, 1, 2, 3, so on. That is 0 union set of natural number. This is whole number set. What is set of integer? Set of integer included negative integers, zero integer, and positive integers. And what is rational number? A number of the form x by y, where y does not equal to 0 and x, y are integer, is known as set of rational number. What is q complement? Q complement is that R means all real minus rationals, means those numbers are irrational number which is not rational. Right? Now we will discuss about the relation. What is relation? A vague definition of the relation is, a relation is basically a set of ordered pair, right? When we are talking about the relation, R is relation from A to B, A and B are set. R is relation from A to B if R is subset of A cross B. What is A cross B? It is Cartesian product of set A and B. Cartesian product of set A and B. Let us consider one example for the relation. Let y is equal to x minus 1 x minus 1 square minus 4. Now, if I put x equal to minus 2, then what is y? Y is 5. Right? If I put x is equal to minus 1, then what is y? Y is equal to 0. If x is equal to 0, then y is equal to 3. If x is equal to 1, then y is equal to minus 4. If x equal to 2, then y equal to minus 3. Right? If x equal to 3, then y equal to 0. Right? Now, for every value of x, we get a corresponding value of y. Putting x here, we got y. Now, consider this ordered pair and we find these relations. Minus 2 is related with 5, minus 1 is related with 0, 0 is related with 3, and what is the relation? This equation represents the relation between x and y. Right? Now consider a set. Minus 2 to 5, minus 1 0, 2 and minus 3. Whether this is the relation, what is the definition of relation? If R is the subset of A cross B, this thing is the subset of A cross B, right? Suppose in this set, minus 2 5, minus 1 0 and 2 minus 3. I added one element 1 4. Whether this is the relation? No, this is not relation, since it is not subset of A cross B. Why? Since 1 is not related to 4. This 1 is not related to 4. Why? By putting this x is equal to 1, we find y is equal to minus 4. That is 1 is related to minus 4, right? Not with 4. Therefore, 1 and 4, these two elements have no relation. So, this set is not relation. Whether 3 0 and 4 5 are relation? Yes, they are related to each other. Now, let us define function. A function, what is function? Basically, we denote the function f from A to B. What is A? A is known as domain of the function and B is known as codomain of the function. Right? Then, in function, if each and every element of the function is uniquely associated with the element of B, then this f is known as function. That is, what is the definition of the function? A function is a relation for which each value from the domain, that is A, is associated with exactly one value from the codomain. Right? Another definition of the function: a function is an equation for which any value of x, that can be plugged into an equation will give the unique value of y. This is known as function. Every function is relation. Function represents relation. Every function is a relation, but converse not to. Right? Now let us see some example. Y is equal to 5x plus 1. Whether it is a function. Y is equal to 5x plus 1. It is a function. Why it is a function? For any value of x, we get a unique value of y. For example, x is equal to 0. Right? X equal to 0. What is y? Y is equal to 1. X equal to 1. What is y? Y is equal to 6. For value of x, we get a unique value of y. Right? Similarly, second, y is equal to x square plus 1. Whether this is the function? Yes, this is function. For any value of x is 0, then y is equal to 1. X equal to minus 1. Y is equal to 2. Right? Similarly, this is the function. This is function. This is function. Y square is equal to x plus 1. Whether this is function? No, this is not function. Why? Suppose x is equal to 1. Then what is y? Y is equal to plus minus square root of 2. It means for a value of x, we get, if x is equal to 1, then y is equal to either square root of 2 or minus square root of 2. That is, for x equal to 1, we get 2 or more than 2 value of y. Hence, it is not a function. X square plus y square equal to 4 is a function? No, it is not a function. What is the reason? Same reason that I have given in equation number 3. For one value of x, we get 2 or more than 2 value of y. Right? Therefore, this 4 is not a function. Now, classification of the function. In this lecture, we will discuss only one type of function, one function. Right? A function f from a to b is said to be 1. Right? A function f from a to b is said to be 1 when if f from a to b is 1 if f of x equal to f of y implies that x equal to y for all x y belong to a. Then let us consider one example. F from z to z and defined as fx is equal to x square. Whether it is a function. See, what is f of 1? F of 1 equal to 1. What is f of minus 1? 1. What is the definition of 1? Fx equal to fy. Right? Means f1 equal to f of minus 1. If these two are equal, this implies that x equal to y. What is x? 1. What is y? Minus 1. Whether these two are equal? No. This is not equal. But fx is equal to fy implies that it means fx equal to fy implies that x does not equal to y. Hence, f is not 1. Right? Hence, f is not 1. Now, consider another example. Second example. F from set of natural number to z and defined as fx is equal to x square. Now, start from fx is equal to fy. Let fx is equal to f of y. This implies that x square is equal to y square. This implies that x is equal to plus minus y. Here two cases are arise. Number 1, x equal to y or x equal to minus y. See, if x is equal to y, then f is 1. But what is x? What about x equal to minus y? X cannot equal to minus y. Why? X is a natural number, right? Then it cannot be negative, right? If this happen, then not 1 1, not 1 1. But this is not possible since minus y does not belong to n, right? Means this always possible. X equal to y. In these two relation, only this is true. Hence, a function from n to z and defined as fx is equal to x square is 1 function. Now consider another example. F from z6 to z6. What is z6? What is z6? Integer modulo 6 means any integer that can be divided by 6. You know, if any number integer divided by 6, then we got a remainder either 0 or 1 or 2 or 3, 4 and 5, right? What about 6? 6 is equivalent to 0, 7 is equivalent to 1. Since if we divide 7 by 6, remainder is 1, right? Then z6 is equivalent to 0, 1, 2, 3, 4, 5. Now this f 0, 1, 2, 3, 4 and 5. Zero, 1, 2, 3, 4, 5. This one is f, right? What is f of 0? F of 0 is equal to, no, first what is fx? Fx is defined as 5 into x. Then what is f of 0? 5 into 0, that is 0. Means 0 is related to 0. 0 is related to 0, right? Now, what is f of 1? F of 1 is equal to 5 into 1, that is 5. Means 1 is related to 5. What is f of 2? F of 2 is equal to 5 into 2, that is 10. And 10 modulo 6, that is 10 divided by 6, remainder is 4. Then 2 is related with 4, right? What is f of 3? F of 3 is equal to 5 into 3, that is 15. 15 modulo 6 is equal to 3, means 3 is related to 3. Similarly, 4 is related to, f of 4 is equal to 20, and that is 20 divided by 6, what is remainder? 2. This is related to 5 related to 1. Note that 0 related to 0, 1 related to 5, 2 related to 4, 3 related 3, 4 related 2 and 5 related to 1, right? See, every element of the domain have different value in the codomain, right? Sorry, have unique image in codomain. Then this fx is equal to 5x is 1 1. Now let us define fx is equal to 2x. Instead of 5, let us consider 2x. Is 1 1 or not? Now, what is f of 0? F of 0 is 0. What is f of 1? 2. What is f of 2? 2 into 2 is 4. What is f of 3? F of 3 is 0. Right? Why 0? 3 into 2 equal to 6. 6 is equivalent to 0. Now see, here 0, 0 and 3 are two elements, right? F of 3 is equal to 0. What is f of 4? 4 into 2, 8 divided by 6, that is 2. f of 5 is equal to 4, right? And this is a function. This is 1 function. This is function but not 1. Why? See why. What is f of 0? F of 0 and f of 3. What definition says that? Fx equal to fy implies that x equal to y. This is definition of 1. What is f0 and f3? Both are equal. Whether 0 equal to 3? No. This is not true. Hence, this function is not 1. This is not 1. Right? Now, let us consider another example. F from Zn to Zn. F from Zn to Zn is 1 or not? F from Zn to Zn is 1 and define and function defined as f of x is equal to ax, and this function is from Zn to Zn, and function defined as this. This is 1. Why 1? Okay. 8 to n. This is 1 only in this condition. If GCD is 1, right? GCD of an is 1, then this fx is equal to ax is 1, otherwise not 1, right? Next, see one example. F from Zn to Zn, fx is equal to ax is 1 if GCD of a and n is 1. Now, how many functions from Z15 to Z15 is 1, right? That many function is 1. The number of integer less than 15 have GCD with 15 is 1. What is the GCD of 1 and 15? That is 1. What is GCD of 2 and 15? That is 1. What is GCD of 3 and 15? That is 3. This is not 1. Fx is equal to 3x is not 1. 4 and 15. 4 and 15 is 1. Right? Then number of GCD of 15 who have 1 means 15 can be written as 15 minus 3. Apply Euler's phi function. 5 minus 1, that is 3 minus 1, that is 4 into 2. Means total 8 function. This one fx is equal to ax. This type of function, 8 function, is 1 function. Similarly, Z25. 25 can be written as, right? 25 can be written as 5 into 5. 5 into 5 is equal to 25, right? Then (25) is equal to 5 into 5, that is 5 square, and 5 minus 1. 5 into 5 minus 1, that is 20. 20 functions of the type fx is equal to ax is 1 from Z25 to Z25. Right? Means 8 function from Z15 to Z15 of the type fx is equal to ax is 1, and 20 function of the type fx is equal to ax from Z25 to Z25 is 1. Right? Now we will stop here. In next lecture we will discuss another type of function, that is onto function, many one function, other function. Okay, thank you.